Okay, so this is for the first half of chapter 7. And so let me get my marker. All right, so AMT chapter 7.1 through 7.4. All right, I just want to kind of go over some of the basics of trigonometry since this is the beginning of trig and we're doing it for the rest of the school year. Um, all right, so here are some things that you need to have memorized. 1 revolution equals 360 degrees, and that equals 2 pi radians. You should also know that 180 degrees equals pi radians. Then some of the important angles that come up over and over and over again are 30 degrees, 45 degrees, and 90 degrees. And so 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. And 90 degrees is pi over 2. And those should just be memorized. Okay, on the next page, I'm going to talk about a 30, 60, 90 and how, if you know that 30 degrees equals pi over 6, then you should be able to take any angle that's a multiple of pi over 6 and know where that angle terminates. Okay, so since pi over 6 equals 30 degrees, I would like to get some 30-degree increments going on my unit circle. And so saying that it's a unit circle just means that the radius is 1. So since each quadrant is 90 degrees, and I know that, let me change my marker to red, starting in standard position means starting on the positive x-axis. So where I'm highlighting here in red, that's the initial side of my angle. And then if my angle is positive, it goes in the counterclockwise direction. And if the angle is negative, it goes in the counterclockwise. I just said that wrong. Positive is counterclockwise, negative is clockwise. All right, so going into the positive direction, counterclockwise, I know this first quadrant is 90 degrees. And so if I split it up into 3 equal parts, it's a little hard to draw on this program, but if those were 3 equal sections, then each section is representing 30 degrees. And so I'm just going to count around my circle. This would be 1 pi over 6 since it's 30 degrees. This would be 2 pi over 6, which of course simplifies to pi over 3. And notice that on the previous page, I didn't suggest that you memorize pi over 3. It does equal 60 degrees, and it's not a big secret. You can know that. I just don't think it's easy to count in 60-degree increments. So anytime I have a multiple of pi over 3, I always change it to be in terms of pi over 6. I'll do an example a little bit later. Okay, then this would be 3 pi over 6. I'm not going to draw the entire line. I'm just going to make tick marks. So this would be 4 pi over 6, which of course simplifies. This would be 5 pi over 6. And then finally, when I get around here, I'm at 6 pi over 6, which of course simplifies to pi. And that was one of the things I said you need to have memorized, is that pi radians is 180 degrees. And I'm going to split up the third quadrant into 3 equal parts. And so this will be 7 pi over 6, 8 pi over 6, 9 pi over 6. Split up the fourth quadrant into 3 equal parts. So this is 10 pi over 6, 11 pi over 6, and finally when I get all the way around, I'm at 12 pi over 6, which equals 2 pi, and that's another one that you needed to have memorized, and that is that 2 pi radians is 360 degrees, or 1 complete revolution. All right, so if you get yourself familiar with this, any angle they give you that's a multiple of pi over 6, you should immediately know where it is on your unit circle. All right, before I do some examples of 30, 60, 90s on my unit circle, let's talk about the ratios you should have memorized for a 30, 60, 90, whether it's standing up tall. So I'm going to put my 30-degree angle here. So if my hypotenuse is 1, and I want it to be 1 because we like to use a unit circle for the angles that come up over and over and over again. So if that's 1, then the short leg is down here opposite the 30-degree angle, and that would be 1/2. And then the long leg is opposite the 60-degree angle, and that would be the square root of 3, square root of 3 over 2. And you just need to memorize those. Now a 30, 60, 90 can also be like this. I call this lying down instead of standing up. This time my 30-degree angle is here, still opposite the short leg. So if my hypotenuse is 1, this time the short leg is here, and that's 1/2, and then the long leg is rad 3 over 2. So the short leg, if your hypotenuse is 1, the short leg is always 1/2, and the long leg is always rad 3 over 2, if your hypotenuse is 1. Now let me change my color to red. If this was on a unit circle and I wanted to label these sides, this is the radius of my circle, so that one would be my R. This would be my Y, and this would be my X, because horizontal is going in the X direction, whereas vertical is going in the Y direction. So on this second triangle that I have here, this is my R, this would be my Y, and this would be my X. So notice the length switch. Let's take the 1/2. In the first triangle, the 1/2 was the X value, but in the second triangle, the 1/2 was the Y value. But both of them, it is the short leg of a 30, 60, 90. Okay, so taking that together with what I did on the previous page about my unit circle, if they want to know the 6 values, 6 trig functions of, let's do 2 pi over 3, so I can demonstrate what I suggest you do when there's a pi over 3. Okay, I don't think it's as easy to count in 60-degree increments, so I'm going to change this to 4 pi over 6. I'm going to draw a picture of it, and as you get more experienced, or if you had Algebra 2 trig last year and you've already learned trig and you're now just solidifying your knowledge of trig, you should be able to do this fairly quickly. So starting from standard position, which is the positive x-axis, I'm going to go in the positive direction. 1, 2, 3, 4 increments of 30 degrees. See how I don't have to convert anything? And I can draw the terminal side of my angle, then draw the perpendicular to the x-axis. You always want to draw the perpendicular to the x-axis to form your reference triangle. Okay, and then I'm going to label the sides of my triangle. So with a hypotenuse of 1, I'm going to label the short leg -1/2. So notice I didn't just put 1/2 for the short leg, but it's negative because from the origin going to the left, your x is negative. And then the long leg is going to be positive rad 3 over 2. So do you see how it's taking all the things that I asked you to memorize or told you you needed to memorize and putting it together to be able to show this triangle, reference triangle. Okay, so if I want the sine, of, now I'm going to write my angle, but in simplified form, 2 pi over 3, and the cosine of 2 pi over 3, and the tangent of 2 pi over 3. Okay, I'm taking these trig functions, sine, cosine, and tangent of an angle. You take trig functions of angles and you get a ratio. So for those of you who are like, I don't know what they're asking me to find, they're asking you to find the ratios. And so the definition of sine, by the way, I didn't summarize that. Let me go to the next page and I'll come back to this page. So you need to know these definitions of sine, cosine, and tangent. Since you take trig functions of angles, I'm going to go ahead and write theta because this is true for any angle. Sine, cosine, and tangent of theta. For sine, we want to memorize y over r. Cosine is x over r. And tangent is y over x. And then once you know those ratios, then you just need to know what trig function is the reciprocal of sine, what's the reciprocal of cosine, and what's the reciprocal of tangent. And once you know those, you actually don't have to memorize those ratios because it's just the reciprocal of the 3 ratios I just wrote. So across from sine is going to be cosecant, across from cosine is secant, and across from tangent is cotangent. And again, you take trig functions of angles, so I'll write of theta. Okay, I want to point something out to anybody who doesn't have this memorized yet. I think tangent and cotangent going across from each other, that's pretty easy to remember because of the names, tangent, cotangent. All right, which, by the way, there's a relationship between those more so than just what you think. You know that they are reciprocals of each other, but there's actually a different relationship that we'll learn when we graph. Okay, but I want to point out that sine starts with an S, and the reciprocal function does not start with an S. It starts with a C. And then cosine starts with a C, but its reciprocal function does not start with a C. It starts with an S. So the S and the C's go together, not the S's and the S's. Okay, so make sure you know which trig function goes across from which. And these are reciprocal functions of each other. And you take the reciprocal of the ratio. Okay, so back to here. I'm going to write my answers in pretty purple. Okay, so sine is y over r. So my y value, oh, let's write those in. This is y. Why is it y? Because it's going up and down. Then my x is the -1/2. Why is it the x? Because it's going in the x direction, left and right. And then this is my radius of my circle. Okay, so sine is defined as y over r. The y is rad 3 over 2. And the reason I'm writing it right away is because I know I'm going to divide by 1. Well, dividing by 1 doesn't change your fraction, so that's why it's so nice to use a unit circle. Okay, so there's my sine of 2 pi over 3, rad 3 over 2. Cosine, I need to know that the definition is x over r, so my x is -1/2. And by the way, any students in my class, if you mess up on the negative sign, I give 0 credit for that. No partial credit for having the correct ratio, but not the correct sign. The signs for X and Y are the only thing that's different between any 30, 60, 90 based on which quadrant it's in. So I insist that you have the signs correct. Okay, and then tangent is Y over X. That's the more complicated trig function for a 30, 60, 90. So I'm going to write up here on the top left. My Y is rad 3 over 2, and I'm dividing by my X, which is -1/2. Well, since these ratios are the ones we're going to use every time, you can see that with tangent, the 2's are going to cancel right away, and so this just equals -rad 3. Okay, so -rad 3 for that. Okay, I'm going to really squeeze in that across from sine is going to be cosecant, across from cosine is going to be secant, and across from tangent is going to be cotangent. All right, and then let me write 2 pi over 3 once, but then I'm just going to go arrow like that because I don't have too much room here. And let's write the ratios that we get when we take the reciprocal of the 3 answers that we already got. And I'm going to switch colors again. Let's go blue. Okay, so the reciprocal of rad 3 over 2, guess what? It never changes. You every single time get 2 rad 3 over 3 when you take the reciprocal and then rationalize the denominator. So you might as well just remember that. I hate to say memorize it, but it's always the same. And when you take the reciprocal of -1/2, we get -2. And then the reciprocal of -rad 3 is negative the square root of 3 over 3. Now you may have to take the reciprocal of that, do some actual math, rationalize your denominator, but every time you do it, it's going to be rad 3 over 3. And so those numbers come up over and over again. And that's where doing your homework and doing those worksheets should be helping you because you're starting to recognize, I hope, that the same numbers come up over and over again. Okay. Okay, I want to look at Andrew's question before I continue. The worksheet from Friday, I do have it, and you said 20 to 23. Okay, Andrew, I actually sent you a text on Remind about those. Those I don't love that they're on this worksheet because we are learning right triangle trigonometry in a unit circle. And so those particular problems, this is on the worksheet that Andrew's talking about. It says AMT assignment in the upper left-hand corner. And so 20 through 23, the hint that I gave you is that you actually want to use SOHCAHTOA. Okay, the ratios that you learned in geometry, that the sine ratio is opposite over hypotenuse compared to what I just did on this example, where I was saying sine was y over r. Because you're absolutely right. You can't tell which one is your x and which one is your y. You do know which one is your r because it's the hypotenuse, but those triangles were drawn in just all different ways. They're not, in a unit circle. And so you wanted to use SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, that doesn't go away. It's still true, but with right triangle trigonometry in our unit circle, you want to be thinking about sine, cosine, and tangent in terms of x's, y's, and r's. Okay, so I hope that helped you, Andrew. All righty, I'm going to continue with my little review. So we talked about a 30, 60, 90, actually increments of 30 degrees going around our unit circle. Let's talk briefly about 45-degree increments. And so you must have memorized that pi over 4 equals 45 degrees. And now, as I start on my positive x-axis for my initial side of my angle, when I go in the positive direction, To get a 45-degree increment, I want to cut my first quadrant in half. Ooh, that's not a very straight line. All right, so this would be 1 pi over 4. And then I'm going to go around and count out pi over 4. So this is 2 pi over 4. Right here would be 3 pi over 4. When I get to my negative x-axis, I'm at 4 pi over 4, and I'll just pause for a moment and say that equals pi, and that should make so much sense to you because I am at 180 degrees, and we know I asked you to memorize that pi radians equals 180 degrees. Okay, I'm not going to do the whole line. I'm just going to go like this, little tick marks like this. So this is going to be 5 pi over 4, 6 pi over 4, which of course simplifies, 7 pi over 4, and when I get all the way around, I'm at 8 pi over 4, and that of course simplifies to 2 pi, which is 1 complete revolution. Okay, all right, so let's just do a little example. Actually, I'll do it right here since I have some room. When I showed you the ratios for a 30, 60, 90 on a unit circle, now I'm going to do the same thing, but with a 45, 45, 90. So if my radius or hypotenuse of my 45, 45, 90 is 1, then the legs are going to be rad 2 over 2. Since they're congruent to each other, that should be pretty easy to memorize. Okay, so on the next page, let's do an example. Let's say they ask you for the 6 trig functions of, excuse me, let's do a negative angle. So 6 trig functions of negative 3 pi over 4. All right, so we're going to eventually do sine, cosine, and tangent of negative 3 pi over 4. Notice since my angle is negative, I'm putting it in parentheses. You do not want to write sine minus 3 pi over 4. That's going to look like a subtraction problem, and it doesn't make sense anyway, but you need to put the parentheses. All right, so since you take, and you're hopefully starting to realize that I'm going to say this a lot, you take trig functions of angles and you get a ratio. So what am I looking for? The ratios. So I'm going to draw a picture, and as I mentioned before, as you get better at this, you might be able to picture this in your brain. As you just kind of think of it, you go, oh, I know exactly where that is, and you don't even have to draw the picture. But for those of you learning trig for the very first time, you absolutely should be drawing a picture. Okay, so I'm going to start in standard position, positive x-axis. Since my angle is negative, I'm going in the clockwise direction. Okay, and I'm just going to count 3 increments of 45 degrees. Here's 1, here's 2, and here's 3. So this is the terminal side of my angle. From that side, I'm going to draw perpendicular to the x-axis. That forms my reference triangle. And so if my hypotenuse is 1, then I know this x value, and I know that's x because it's going in the x direction, is negative rad 2. Oops, sorry, accident. I said it right, and I wrote the wrong number. Negative rad 2 over 2. And then my y also is negative. Okay, and let's write that this is y equals, and this is x equals, so you know which one I'm looking at. Okay, they both happen to be the same because we're in the third quadrant. Both my x and my y are negative, but I want to make sure you know which one's which. Okay, so for sine, that's y over r, so I get negative rad 2 over 2. Cosine is x over r, well, that's also negative rad 2 over 2. And then tangent, you guys please think before you go doing a bunch of math. This is negative rad 2 over 2 divided by negative rad 2 over 2. Aren't those numbers exactly the same? Cancel, cancel, and a negative over a negative is positive, and so I get positive 1. That should be that easy. Okay, now for my reciprocal functions, of course, I have cosecant, secant, cotangent of this negative 3 pi over 4, negative 3 pi over 4, negative 3 pi over 4, and those are trig functions of an angle. So of course I'm looking for a ratio, but I don't even need to think about the definitions of these ratios because they are the reciprocals of the 3 that we just found. So every time you take a reciprocal of rad 2 over 2, you're going to get rad 2. And of course the negative comes across also because reciprocals don't change sign. So that one's negative rad 2. Secant is also negative rad 2, and the reciprocal of 1 is 1. Okay, so those are my 6 answers. Okay, finally, let's talk about quadrantal angles. Quadrantal angles are angles that terminate on an axis. So let me just draw my unit circle. Oh, that wasn't great. Okay. And so if I'm talking about a 90-degree angle, I'm going to start in standard position and I would terminate right here. I should do this in a different color. Okay, 90 degrees would be on the positive y-axis. And if I wanted I don't know why I'm doing it in degrees, but just to mix things up a little bit, and I'll go back and relabel those in radians. If I wanted 180-degree angle, well, I start on the black positive x-axis and then go 180 degrees, and doesn't it terminate on the negative x-axis? And so let's go ahead and continue. If it was 270 degrees, our angle would terminate on the negative y-axis, and then I could have a 360-degree angle, and it goes all the way around my circle and terminates on the positive x-axis, exactly where we started. Okay, so just to talk about radians, this is probably the one that, at least in my class, we've discussed the least. So starting at 0 radians, this would be pi over 2. This would be 2 pi over 2. I'm going in increments of 90 degrees because I've asked you to memorize that pi over 2 equals 90 degrees. So 1 pi over 2 up at the positive y-axis, 2 pi over 2 at the negative x-axis, 3 pi over 2 on the negative y-axis, and then all the way around would be 4 pi over 2, which of course equals 2 pi, and that should make so much sense because 2 pi is 1 complete revolution. Okay, so now to be able to get trig functions, let's do all 6 of them, sine, cosine, and tangent. Let's do 3 pi over 2. And of course, they could have said 270 degrees, or they could have said negative 90 degrees, or negative pi over 2. All right, so you take trig functions of angles and you get ratios. So I'm looking for the ratios. So at 3 pi over 2 down here at the very bottom, I'm going to do it on this top circle since there's a little bit more room. Okay, here's my terminal side, and if you try to draw a reference triangle, you can't, because the way you draw a reference triangle is you draw perpendicular to the x-axis. Well, that's just going to give you a line segment that goes right back to the origin. It doesn't give you a triangle, but that's okay. Here's how quadrantal angles work. You want to label this point. So I'm going to consider that my radius is 1, so it's a unit circle. And then wouldn't that point in my xy coordinate plane be the point 0, negative 1? And if you prefer to write r equals 1 and then say x equals 0 and y equals negative 1, feel free to do that. And then you just need to know the definitions of your trig functions. So I know that sine is y over r. My y is negative 1 over positive 1, and so I get negative 1 for my sine ratio. Cosine is x over r. Well, x, maybe I should write these here. This was negative 1 over 1. X over r is going to be 0 over 1, and that equals 0. And then tangent is y over x. My y is negative 1. My x is 0. And when you divide by 0, that is undefined. Okay, so those are the 3 answers for sine, cosine, tangent. I don't have enough room to write them across like I normally do. So I'm going to write them right here. Cosecant, secant, and cotangent. Notice I always go in the same order with my 6 trig functions. So all 3 of those reciprocal functions of 3 pi over 2, all I have to do is take the reciprocal of my 3 first answers. So the reciprocal of negative 1 is negative 1. The reciprocal of 0 is undefined, and the reciprocal of undefined is 0. And so those are the 3 answers for cosecant, secant, and cotangent of 3 pi over 2. And that's what you need to know to be able to do trig functions, take trig functions of quadrantal angles. Okay, I'm going to go back to page 1. I just want to summarize kind of everything that I just reviewed. You absolutely have to have these 5 things memorized. That 1 revolution is 360 degrees or 2 pi radians, and the rest. I'm not going to read them all to you. Page 2, being able to count in increments of pi over 6, knowing that it's 30 degrees and that you cut a quadrant into 3 equal parts to get a 30-degree increment, and you should be able to go in any direction, any multiple of pi over 6, and know where your triangle is. Okay, and let me just add to this picture right here. If I wanted a 30-degree reference angle and I draw my perpendicular to the x-axis, notice that you can have a 30, 60, 90 lying down like I just showed, or if I do it on my 2 pi over 6, which is pi over 3, notice that's also a 30, 60, 90, but it's standing up tall. Okay, so you have 30, 60, 90s, 2 different possibilities within each quadrant. Okay, so keep that in mind. And by the way, a very common mistake. A 30, 60, 90, as I have shown right here in the first quadrant, is either like this. That's not the greatest picture. Or it's like this, standing up tall. Okay, but what it's not, if it's a 30, 60, 90, is draw that. Hold on. This is not what a 30, 60, 90 looks like. And what I'm trying to purposely draw is what I see a lot of students draw. They'll draw this. Well, it sure looks like a 45, 45, 90. And how in the world are you going to know which one is your short leg and which one is your long leg if they look like they are congruent legs? Okay, so do not draw 30, 60, 90s that look like 45, 45, 90s. So when you consider cutting up a quadrant into 3 equal parts, make them look like 3 equal parts so you can tell on a 30, 60, 90 that's lying down, where's the short leg, where's the long leg? And then a 30, 60, 90 that's standing up tall, where's the short leg, where's the long leg? You have to know which one's which. So you can label your short leg 1/2 and your long leg rad 3 over 2 correctly. Okay, so then page 3, I have my 30, 60, 90 standing up tall, lying down, showing the 1/2 and the rad 3 over 2, as well as the radius of 1. Then we did an example where the angle they gave us was 2 pi over 3. We changed it to 4 pi over 6 so that we could count in increments of 30 degrees, which I recommend doing because it's easier than counting in 60-degree increments. Then you get this triangle, you label it, of course, considering whether the x and or the y are positive or negative. R, by the way, is always positive no matter what quadrant we're in. All right, moving on to page 5. We talked about the definitions of sine, cosine, and tangent in terms of x's, y's, and r's, and then knowing the reciprocal functions. Okay, and then I introduced the 45, 45, 90, counting around my circle in increments of pi over 4, because you must know that pi over 4 equals 45 degrees. Then I summarized the ratios of a 45, 45, 90. If your hypotenuse is 1, then the 2 legs are both rad 2 over 2. We did an example of taking the 6 trig functions of -3 pi over 4, so obviously a 45, 45, 90. Then we discussed quadrantal angles, angles that terminate on the x or y axis, positive or negative x or y axis. And then we did an example of finding the 6 trig functions of that. Where is that? There it is. That was on that page. Okay, now I'm ready to answer your questions. Okay, that isn't everything that you need to know, but those are a lot of the basics. Okay, Katie is asking for some questions on worksheet 3, which I have. Okay, 31, 37, and 41. Okay, number 31, let me write worksheet number 3, number 31. Okay, they gave you cosine of 45 degrees. And then it doesn't say this, but it is implying times sine of 210 degrees because there's no symbol. Just like when you write 3x, you mean 3 times x. So when there's no symbol, it means times. Okay, now there's a minus sign. And then it says sine of 30 degrees, no symbol, so it means times cosine of 135 degrees. Okay, I think this is a great way to get organized. I'm going to put parentheses underneath each of these trig functions of these different angles. By the way, there's 4 different angles. So if you don't have your 45, 45, 90s and 30, 60, 90s memorized, you're going to have a hard time with this. This is 4 problems in one. Okay, I'm going to draw just a quick little picture. Here's my 45-degree angle, and I want the cosine of it. And so cosine I know is x over r, so that's rad 2 over 2 divided by 1. And so I'm going to write this in red, rad 2 over 2. Okay, sine of 200 degrees. I'm going to do this one in red. also? So 210 degrees. I'm going to start in standard position. I'm going to go all the way around to halfway around my circle to the negative x-axis. That's 180. I know I need to go 30 degrees more. So I'm going to go like this and like this. Okay, let me get rid of that last tick mark. I want one only, one increment of 30 degrees past 180. And so I'm here when I draw my perpendicular to the x-axis. This isn't the greatest picture, but I can see that this is the short leg, -1/2, and this is the long leg, -rad3/2, and a hypotenuse of 1. Now I want the sine of that, so sine is y/r. My y is -1/2 divided by 1, which doesn't change it, and so there you go. All right, sine of 30 degrees is next. So first quadrant, one increment of 30 degrees. I'm going to draw the perpendicular to the x-axis. I can see that my y is 1/2. And as you start to get a little more experienced with this, I knew I wanted to draw a 30-degree angle, actually a 30, 60, 90 reference triangle with a 30-degree reference angle. But I want the sine of it, and I know my definition of sine is y/r. So why label the entire triangle? Isn't the 1/2 the only thing I'm interested in, the y value? Okay, I know it's divided by 1, my radius, but that's all you need to do. So don't do more than you need to do, and that will come with experience. All right, 135 degrees, starting in standard position, going in the positive direction. I'm going to go 90 degrees and then another 45 degrees. So here's my reference angle, reference triangle rather. Okay, and since I want cosine, I'm just going to label the x. It's -rad2/2. So -rad2/2 for cosine. And now I'm ready to do the math. Okay, let's switch to color. Guess red. Okay, so my first two fractions, when I multiply them together, I get -rad2 divided by 4. Do you agree you are multiplying 2 times 2 in the denominator? Then in the second, the third and fourth trig functions, there's a minus sign in front of my 1/2, and then my rad2/2 is negative. So a negative times a negative is positive, so I get positive rad2/4. And then negative rad2/4 plus positive rad2/4 gives me a final answer of 0. Now that seems like a whole lot of work to end up getting 0, but no matter what the answer is, you need to show your work, do each individual part. This is a 4-question problem actually, and then doing the arithmetic to get a final answer of 0. All right, Katie, there is your answer. Okay, number 37 on the same worksheet. Okay, 37 says cotangent squared 330 degrees minus cosecant squared of 330 degrees. All right, so the good news is we only have one angle, so I'm going to draw a picture of that down here in the lower left-hand corner. 330 degrees, I notice, is very close to 360, so I'm going to consider going in the positive direction, going all the way around my circle to 360, and then saying I want to go back 30 degrees. So see how I'm cutting that fourth quadrant into 3 equal parts. I'm going to actually erase the last tick mark so it doesn't get in my way. And so this is my terminal side. I'm going to draw perpendicular to the x-axis. Oh, do I hear a puppy? Bear, is that you? Come here, Bear. Bear, come here. Snickers, is it you? Oh, I thought I heard a puppy. Oh, I want a puppy to say hi to my students. She has cheese. That's my daughter. Okay, you don't get to see Bear, sorry. Okay, so the other thing that I want to talk about, and I'm glad you asked this question, Katie, is this square right here. Okay, I'm going to read it to you the way you say it. It's cotangent squared of 330 degrees minus cosecant squared of 330 degrees. But what you actually do is you find the cotangent of 330 degrees, and when I say find it, I mean find the ratio, because you take trig functions of angles and you get a ratio. So I'm going to write the ratio in these red parentheses, and then I'm going to square it. Then I have a minus sign. I'm going to find the cosecant ratio of 330 degrees, and then we'll square it, and then we'll figure out what our final answer is. Okay? Okay, so in my picture down here, if my radius is 1, the short leg is -1/2, the long leg is rad3/2. I hope that you're recognizing. I mean, hopefully in the past couple of weeks you've recognized it, but especially seeing this all in one study session, you should be realizing that, oh, I just need to memorize all these things that she said I need to memorize. And this will actually end up being easy because the 30, 60, 90 doesn't change. All right, and then how did I know that the rad 3 over 2 is positive? Because going to the right of the origin in the x direction means that it's positive. Let me label that this is x. And then how did I know my 1/2 was negative? Because from plotting points from the origin, when you go down in the y direction, that is negative. And so that's my y. And then, of course, the 1 is my r. Okay, now cotangent, I'm going to stop and think to myself. I know cotangent is the reciprocal of tangent, and tangent is y over x. So I'm going to go x over y. And I'm going to do a little bit of work outside of my red parentheses. So my x is rad 3 over 2. My y is negative 1/2. My 2's are going to cancel like we talked about before, and we get negative rad 3. Now, a problem like this on your test will absolutely be on the no calculator part, and you need to show that this is negative. Okay, now when I square it, it'll become positive, but you need to show in your work, and that's why it will say show your work. That's right, show work. Okay, and I'm going to be looking that you have negative rad 3 before you squared it, so you need to show that. All right, now cosecant squared of 330 degrees, it's the same angle. And so I want cosecant. Well, I know that's the reciprocal of sine. So watch how I'm going to do this one a little differently than I did the first one. The first one I said I know cotangent is the reciprocal of tangent. I said the definition of tangent, y over x, and then I took the reciprocal of that and said x over y, and that's what I used to get my ratio. This time, however, I'm going to say since cosecant is the reciprocal of sine, let's actually find the sine of this angle. Isn't it negative 1/2? There's my sine, and I can just take the reciprocal of it. And don't I get negative 2? So now when I square negative rad 3, I end up getting positive 3. Then I have my minus sign. When I square negative 2, I get positive 4, and then 3 minus 4 is negative 1. And that's my final answer. Okay. Katie's last question, number 41 on the same worksheet. All right, 41 says secant of 30 degrees divided by cosine of 30 degrees. All right, so I'm going to draw a 30-degree angle in standard position, draw the perpendicular to the x-axis when my hypotenuse is 1. The short leg is 1/2. The long leg is rad 3 over 2. Of course, everything's positive because we're in the first quadrant. Okay, so now I'm ready to start writing my ratios because you take trig functions of an angle and you get a ratio. That you should say that over and over and over again to yourself, because when we get to calculator stuff, that is going to be so important. Okay, secant, I know is the reciprocal of cosine. So I look at my triangle. I know the cosine is rad 3 over 2. And I've rationalized the reciprocal of that often enough that I know the reciprocal of rad 3 over 2 is 2 rad 3 over 3. And then I want to divide that by the cosine of 30, which I just said was rad 3 over 2. Okay, so that's finding the values. Now I'm going to simplify that. If I take my numerator, 2 rad 3 over 3, and then instead of saying divided by rad 3 over 2, I'm going to say multiplied by its reciprocal. And I'm purposely not going to rationalize that. Can you see that your rad 3's are going to cancel? And I get 4 in the numerator, 3 in the denominator, and that's my answer. Okay, Katie, there are your questions. Andrew, I answered yours. All right, Sarah Williams, how much of the review problems and worksheets will we see on the test? You know what? The worksheets are very reminiscent of, well, I'm going to say worksheet 1, worksheet 2, and worksheet 3. All of those are to help you practice 30, 60, 90s, 45, 45, 90s, and quadrantal angles. Those are so important, and I keep trying to say this in class, but to all of you, all the 30, 60, 90s, 45, 45, 90s, and quadrantal angles, those are not a situation where you're going to do them on this test and then never see them again. You are going to see those the rest of the semester, the rest of the school year. 30, 60, 90s, 45, 45, 90s, and quadrantal angles are so important, and they come up over and over and over again. So that's why you're seeing them so much on these worksheets. We've got to get you guys used to those because they come up so often. Okay, so it's not a one and done. Like, okay, once this test is over, I'll never need that again. You're going to use it the rest of the school year. All right. Gabe, worksheet 3, 59 and 63. All right. All right. What I love about these, worksheet number 3, number 59, is you're getting to see practicing everything that I just reviewed before we started going over your questions. Here I see cosine squared of 3 pi over 4. Well, look at that. That's a multiple of pi over 4. I know I'm going to have a 45, 45, 90. Then it says minus sine squared of pi over 3. Well, I didn't memorize pi over 3, even though I know it's 60 degrees. But I know I'm going to change that to the equivalent of 2 pi over 6. And I go, oh, it's going to be a 30, 60, 90. Okay, so I know this is going to be find the ratio and then square it, minus find that ratio and then square it. So I'm setting that up first. Then down here, I'll draw pictures. Okay, 3 pi over 4, that's 3 increments of 45 degrees. So starting in standard position, I'm going to go 1, 2, 3 tick marks of 45 degrees. Do you see how easy that is if you know that pi over 4 is 45 degrees? Then I draw perpendicular to the x-axis. I'm looking at my question and I see that it's cosine. So I'm only going to label one thing on this triangle. It is negative rad 2 over 2 for my x. I know that my r is 1. And so the cosine is negative rad 2 over 2. Okay. Then I'm going to draw a picture of pi over 3. I'm going to think of pi over 3 as 2 pi over 6, so I can count in 30-degree increments. So it's 1, 2 increments of 30 degrees. There's my terminal side. I'm going to draw perpendicular to the x-axis, and there's my 30, 60, 90. Now this time I want sine, and so if my radius is 1, my hypotenuse is the square root of 3. Excuse me, I just said that wrong. If my hypotenuse is 1, my radius is 1, then the y value is rad 3 over 2. And that's all I want for the sine. So rad 3 over 2. And it's positive because it's going up. Okay, so now I'm ready to do the arithmetic. So I square that negative rad 2 over 2. And again, remember, show your work. You need to show that that's negative. When I square it, it's going to become positive 2 over 4. And then for the second term, I have minus 3 over 4, and so 2/4 minus 3/4 is negative 1/4, and there's my answer. Okay, okay, that was 59. All right, and then Gabe also asked for number 63. All right, 63 says tangent of pi over 6, and it doesn't say times, but if you want to put a dot there to show yourself that it's times, cotangent of pi over 3 plus tangent of pi over 4. All right, it almost seems like they forgot to write a fourth trig function, but that's all right. We're finding the value, so we will find that ratio, multiply them together, and then plus that ratio. Okay, let's draw some pictures down below. So pi over 6, and I want tangent. So that's a 30-degree reference angle. Draw my perpendicular to the x-axis. I'm going to write everything this time. 1/2 for the short leg, rad 3 over 2 for the long leg. Since tangent is y over x, tangent is y over x, I want 1/2 divided by rad 3 over 2. My 2's are going to cancel, so I have 1 over rad 3. But I've rationalized this so many times, I know it's rad 3 over 3. Okay, so there's tangent of pi over 6, rad 3 over 3. All right, next I want cotangent of pi over 3. And so I'm going to think of pi over 3 as 2 pi over 6. So this time I have a 60-degree reference angle. Okay, my r is 1, my short leg is 1/2, long leg is rad 3 over 2. And since that's cotangent, I know cotangent is the reciprocal of tangent. Tangent is y over x, so that makes cotangent x over y. So I have 1/2 divided by rad 3 over 2. Well, look at that. That's exactly what we just did below. So of course it's going to be the same, rad 3 over 3. Okay, and then finally, tangent of pi over 4. I'm going to draw the picture for you, but if you can figure this out without drawing the picture, more power to you. This is a 1, this is rad 2 over 2, this is rad 2 over 2, tangent is y over x. If I take rad 2 over 2 and divide it by rad 2 over 2, I know they're going to cancel completely and give me 1. And so now I'm ready to do my arithmetic. My rad 3 times rad 3 is 3. 3 times 3 is 9. And so I just have 1 and 1/3, right? Because 3/9 simplifies to 1/3 plus the 1. So 1 and 1/3 as a mixed number. And as an improper fraction, that would be 4/3. And there you go. Okay, that was Gabe. Okay, Sarah is asking for worksheet 3, number 46. Okay. Okay, number 46. All right. Okay, 46 says sine of pi over 3 plus 6, and there's no symbol, but you can write a times sign if you'd like, times 6, plus 6 times cosine of pi over 4. All right, so pi over 3, by the way, as you get better and better at this, you don't have to draw these pictures if you don't feel like you need to. Okay, I can picture pi over 3 in my mind's eye and know that sine is rad 3 over 2. But if you need to draw it, I'm going to go 2 increments of pi over 6 because pi over 3 is equivalent to 2 pi over 6. And since I know pi over 6 is 30 degrees, then I'm doing 2 increments. Okay, so here's my terminal side. When I draw perpendicular to the x-axis, I have a 30, 60, 90, where if this is 1, then this is rad 3 over 2. This is 1/2, but I really don't need to write that because I know I want the sine of pi over 3. And so it's rad 3 over 2. Then a plus sign, 6, and then I'm going to put parentheses. Now I want the cosine of pi over 4. Well, I have to know that pi over 4 is 45 degrees. When I draw my perpendicular to the x-axis, if that's 1, this is rad 2 over 2, and this is rad 2 over 2. I want cosine, that's the x over r, so rad 2 over 2. Okay. I'm just going to write this as one fraction, I guess. What number is this? 46. I don't have my answer key on that one. Okay, so since both of them have, by the way, this 6, you might want to write it as 6 over 1, so you don't do anything crazy. Okay, my denominator for the first fraction obviously is 2, but my denominator for the second fraction, second term, is also going to be 2. So I have a common denominator of 2. So I'm going to write one fraction and write 3 plus 6 rad 2 all over 2. And there's my answer. Okay, not very exciting, but nothing combines, nothing cancels. I suppose you also could have written it as the square root of 3 over 2. Let me fix that square root of 3. Okay, square root of 3 over 2, and then you could have said that your 6 and 2 cancel to give you plus 3 rad 2. You can write that as 2 separate terms as well. Okay, that's another way of writing it. I wrote it as one term, one fraction. Both of those are acceptable. Okay, let's see. So Katie, yes, I'm on Katie's question. Number 61 on worksheet 3. Yes, I can do that. And 6:22, so we have a few more minutes. If anybody has any other questions, please ask. So this is worksheet number 61. Okay, cosine of 5 pi over 3 divided by sine of 5 pi over 3. So when the angle is the same, then you only have one picture to draw. Okay, so I'm going to think of 5 pi over 3, pi over 3 as 10 pi over 6. I just still contend that it's easier to count in increments of 30 degrees. Okay, now I'm going to start in standard position right here at the positive x-axis, but I'm going to go all the way around my circle. I know that wasn't the greatest. Okay, all the way around. And so isn't that 12 pi over 6? See, I noticed that 10 pi over 6 is very close to 12 pi over 6. But I need to go back 2 increments of 30 degrees. So I'm doing 2 tick marks. Here's my terminal side. I'm going to draw perpendicular to the x-axis. It's not the greatest triangle, but I can tell that this is the short leg of 1/2. This is the long leg of negative rad 3 over 2 because the y is going down. And so I need all of that for this problem. So for cosine, the numerator, I want 1/2. For sine, the denominator, I want negative rad 3 over 2. And so don't the 2's cancel? I get 1 over negative rad 3. And when I rationalize that, I get negative rad 3 over 3. And that is my final answer. There you go. Okay, nobody asked any questions while I was doing that problem. All right, you're welcome, Katie. Okay, if anybody has any other questions, ask quickly. We still have 6 minutes, but if nobody asks any other questions, then we're going to say goodbye. So advice while I'm looking to see if anybody asks any other questions is memorize everything that I told you to memorize and practice, practice, practice those 30, 60, 90s. By the way, I do not want you to think that everything that we did on here tonight is all you need to know. You still need to know how to convert degrees to radians. You know, I'll make a little comment about that. If I give you any kind of number of degrees and I say convert it to radians, well, there's one of the things I asked you to memorize. You want to get rid of degrees, end up with radians, and so you need to know that there's 180 degrees that's equal to pi radians. Your degrees will cancel and you'll end up with radians. And so this is your multiplier, multiplying by pi radians over 180 degrees. Conversely, if I give you a number of radians, okay, and it doesn't matter if it's the number 4 or something like, I don't know, 7 pi or something like that, if I ask you to convert it to degrees, then you want to get rid of radians and end up with degrees. So there are 180 degrees in pi radians. And now notice the radians cancel and you end up with degrees. So now this is your multiplier. So notice the difference, pi over 180 or 180 over pi. You don't have to memorize which one's which. You just have to know that pi radians equals 180 degrees. And then the units will tell you what to multiply and what to divide by. Because if you're getting rid of radians, then the radians need to go on the denominator. If you're getting rid of degrees, then your degrees need to go in the denominator. Okay, other things. You need to know how to convert degrees, minutes, seconds to decimal degrees or to decimal radians. What else was on our quiz that is more than just what I showed you? Oh, the identities, knowing the reciprocal identities as well as the quotient identities, and how to do that in your calculator. Anyway, so there's, certainly a few more things that we have learned, but the 30, 60, 90, 45, 45, 90, and quadrantal angle thing, and all the memorized radians and how to show it on the unit circle and ratios and everything, very, very important. Okay, I hope that was helpful to you guys. I will see you, my students, tomorrow, and have a nice evening. Good night.